Module 4, Lesson 28, Two-Step Problems, All Operations. Our learning targets for today are: I can calculate the solutions of two-step equations by using their knowledge of order of operations and the properties of equality for addition, subtraction, multiplication, and division. And I can check to determine if my solutions make the equations true. Our first example. Juan has gained 20 pounds since last year. He now weighs 120 pounds. Rashid is 15 pounds heavier than Diego. If Rashid and Juan weighed the same amount last year, how much does Diego weigh? Let J represent Juan's weight last year in pounds, and let D represent Diego's weight in pounds. So we're going to start by drawing a tape diagram that is going to represent Juan's weight. So I'm going to draw a rectangle, and then I'm going to cut it into two boxes. This first box will be J, and the second box will be 20, and then the whole thing is going to be 120. So this is Juan. Now we're going to draw a tape diagram to represent Rashid's weight. So I'm going to draw a rectangle, cut it into two boxes. Rashid is 15 pounds heavier than Diego, so I'm going to put 15 in the one box, and then D in the second box. Okay, so this is Rashid. And then lastly, we're going to draw a tape diagram for Diego. So I'm going to draw a rectangle, and inside the rectangle, I am just going to put D, and this represents Diego. So now we're going to write an equation to represent Juan's weight. So the equation is going to be J plus 20 is equal to 120. And now we're going to write an equation to represent Rashid's weight. So we know that Rashid weighs 15 more pounds than Diego, so we're going to start with D plus 15. And we know that Rashid and Juan weighed the same amount last year, so we're also going to add 20 to it, and then we're going to equal it to 120. So lastly, how can we use Diego's tape diagram or the two equations that we came up with to answer the question of what is Diego's weight in pounds? So by combining 15 and 20 from Rashid's equation, we can use our knowledge of addition identities to determine Diego's weight. And the final tape diagram can be used to write a third equation. And our third equation is going to be D plus 35 is equal to 120. And we can use our knowledge of addition identities to determine Diego's weight. So now we're going to use our last equation that we came up with to find Diego's weight. So we're going to have D plus 35 is equal to 120. And when we're solving algebraic equations, we want to get the variable by itself. So we want to get D all by itself. So what we're going to do is we're going to subtract 35 from both sides. And by doing this, this is going to cancel out the 35s over here. So we're going to be left with D, which is what we want. And we can see that D is going to be equal to 85. So we can say that Diego's weight is 85 pounds. And if you're not sure if this is correct, we can plug 85 back into our equation. So we'll have 85 plus 35 is equal to 120, and 85 plus 35 is 120, so that is equal to 120, so we can say that our answer of 85 pounds is correct. Our second example is, Marissa has twice as much money as Frank. Christina has $20 more than Marissa. If Christina has $100, how much money does Frank have? Let F represent the amount of money Frank has in dollars, and M represent the amount of money Marissa has in dollars. So we're going to start by drawing a tape diagram for Frank. So we're just going to have one rectangle, and inside it we're going to have a single F. So this is Frank. And then we are going to draw a tape diagram for Marissa. So I'm going to draw a rectangle. I'm going to cut in half, and inside the two boxes I'm going to put F and F. And this is Marissa. And then lastly, I'm going to draw a third tape diagram. So here's our rectangle. I'm going to put it into two squares. So one's going to be M, one's going to be 20, and the whole thing is going to equal 100. And this is Christina. So which tape diagram provides enough information to determine the value of the variable M? So the tape diagram that represents the amount of money Christina has is the one we're going to use. So I'm going to write it over here. So we're going to have M plus 20 is equal to 100. And now we can solve. Remember, we want to get the variable by itself, so we want M all by itself. So we're going to subtract 20 from both sides. This gets rid of the 20 over here, so we're left with M. And then 100 minus 20 is equal to 80. Remember, if you're not sure if this is correct, we can go back in and we can check it. So we can have 80 plus 20 is equal to 100. So 100 is equal to 100. So our answer is correct. So M is going to equal $80. Now that we know Marissa has $80, how can we use this information to find out how much money Frank has? So we can write an equation to represent Marissa's tape diagram since we know the length is 80. So our equation is going to be 2F is equal to 80. Okay, and we still want to get F by itself. So when we are multiplying, the opposite of multiplying is dividing. So we're going to divide both sides by 2. The 2's will cancel out, so we're left with F. And 80 divided by 2 is 40. So Frank has $40. And we can go back and we can check this. So it would be 2 times 40 is equal to 80. So 2 times 40 is 80, which is equal to 80. So our answer of $40 is correct. Our next example. Rihanna is twice as old as Madeline, and Laura is 10 years older than Rihanna. If Laura is 50 years old, how old is Madeline? Let M represent Madeline's age in years, and let R represent Rihanna's age in years. So we're going to start by drawing a tape diagram to represent Rihanna. So I'm going to draw a rectangle, and I'm going to cut it in half. And in one box, I'm going to put M and M because she's twice as old as Madeline. So this is Rihanna. Secondly, I'm going to draw another tape diagram for Madeline, and she's just going to have one single box with an M. And then I'm going to draw a tape diagram for Laura. And Laura is 10 years older than Rihanna, so one box is going to have R. The second box is going to have 10. And we know that Laura is 50 years old, so this whole box is equal to 50. So now we're going to solve Laura's equation to find R. So this is going to be R plus 10 is equal to 50. And by finding R, we can find Rihanna's age. So we want to get R by itself, so we're going to subtract 10 from both sides because we want to do the opposite of addition, which is a subtraction. So this cancels out the 10. So R is by itself, and 50 minus 10 is 40. So we know that Rihanna is 40 years old, and she is twice the age of Madeline. So now we need to find Madeline's age, which the equation we're going to use is the equation we made for Rihanna, which is 2M is equal to 40. Okay? We want to get M by itself, so we're going to divide both sides by 2, which cancels out the 2. And then we have left M, and 40 divided by 2 is 20. So Madeline is 20 years old. All right. Carly has 90 apps on her phone. Braylon has half the amount of apps as Thesis. If Carly has 3 times the amount of apps as Thesis, how many apps does Braylon have? Let B represent the number of Braylon's apps and T represent the number of Thesis's apps. So we're going to start by drawing some tape diagrams. I'm going to start with Thesis, which is just going to be one rectangle with a T inside. Next, I'm going to draw a tape diagram for Braylon. And I'm going to cut it in half, and one square is going to be B, and one square is going to be B. And then lastly, I'm going to draw a tape diagram for Carly. And we know that she has 3 times the amount of apps as Thesis, so rectangles will be cut into 3 with T, 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 and we know she has 90 apps. So now we're going to start by solving the equation for Carly, which is 3T is equal to 90. So we're going to divide both sides by 3. So this gives us T is equal to 30. So we know that Thesis has 30 apps. So now we can find how many apps Braylon has in the equation. And we know that Braylon has half the amount of apps that Thesis has. So it's going to be 2B is equal to 30. So we're going to divide both sides by 2, which gives us B is equal to 15. So Braylon has 15 apps. And remember to always include your unit. Reggie ran for 180 yards during the last football game, which is 40 more yards than his previous personal best. Monty ran 50 more yards than Adrian during the same game. If Monty ran the same amount of yards Reggie ran in one game for his previous personal best, how many yards did Adrian run? Let R represent the number of yards Reggie ran during his previous personal best, and A represent the yards Adrian ran. So we're going to start by drawing our tape diagrams, and I'm going to start with Reggie. So I'm going to draw a rectangle. We know that he ran 180 yards, which is 40 more yards than his personal best. So we're going to have 40, and then we're going to have R. So this is Reggie. Next, I'm going to draw a tape diagram for Monty. And Monty ran 50 more yards than Adrian, so we're going to have 50, and then A. And then for Adrian, we're just going to have one single rectangle with A inside. So we're going to start by solving the equation for Reggie. So we're going to have R plus 40 is equal to 180. So we're going to start by subtracting 40 from both sides so we can get R by itself. So R is going to be equal to 140. So now we can solve the equation for Monty. So we're going to have A plus 50, but he also ran the same amount of yards as Reggie, so we're also going to add in that 40 yards, and then it is equal to 180. So we can combine the 50 and the 40 for a total of 90. So now we're going to have A plus 90 is equal to 180, and now we can subtract 90 from both sides. So we are going to have A is equal to 90. So Adrian ran 90 yards. And our last example for today, Lance rides his bike downhill at a pace of 60 miles per hour. When Lance is riding uphill, he rides 8 miles per hour slower than on flat roads. If Lance's downhill speed is 4 times faster than his flat road speed, how fast does he travel uphill? Let F represent Lance's pace on flat roads in miles per hour, and U represents Lance's pace uphill in miles per hour. So I'm going to write the equation first for uphill, or the tape diagram, I should say. And so that's going to look like this. We're going to have a rectangle, U in one, 8 in the other, and it's going to be equal to F. And then for downhill, it's going to be equal to 60. And then our rectangle is going to be cut into 4. And F will be inside. So we're going to start by solving the equation for downhill. So 4F's is going to be 4 times F, or 4F, which is equal to 60. We want to get F by itself, so we're going to divide by 4. So F is going to be equal to 15. And now that we know what F is, we can solve the uphill one, because we now know that the tape diagram has a length of 15. So we're going to have U plus 8 is equal to 15. We're going to subtract 8 from both sides. So U is going to be equal to 7. So Lance travels at a pace of 7 miles per hour when he goes uphill. And that concludes our lesson for today. So now you can go complete the problem set.